So now we're going to again do A, B, and C. I know, boring. We keep doing the same similar examples so you can see all the different ways of doing that one type of example, more easily allowing you to do more difficult questions in the future, relating them back to the more simple examples. So rearranging all of the letters A, B, C two at a time, no restrictions, meaning repeats are allowed. Well, that's blank time comma blank, or blank times blank, or whichever you like. And we can do A, B, or C. And again, no restrictions, so repeats are allowed. So A, comma, B, comma, C, and that's 3 times 3 to equal 9. Now, how can we think about this a little bit differently? Well, let's list them all out. So we have two at a time. A, B, B, C, C. Now we're going to call this case number 1. Two of the same letter. Then we have a different case. A, B, B, A, B, C, C, B, A, C, and C, A. And we know that's case number 2, being two different letters. Now the notes are a little bit shifted around, but how are we going to do that? Well, in the first example, what we're doing is we're using a combination where we have 3 examples to choose from, and we're just simply choosing one of them. And then we're adding cases together. We add cases together. In the other example, we have 3 things to choose from, and we're choosing 2 of them. But that only counts A, B, A, C, C, B, etc. 3 of the examples. And we have to times that by 2, because A, B can be B, A. And that considers 3 plus 3C2. Feel free to work it out, but 3 times 2 factorial, which is simply 3 plus 6, also 9. The same 9 we got earlier. So in red, from above, the 3 different ways in case 1 is 3C1, or 3. And the 6 different ways is 3C2 times 2C1. Now, cases are much more difficult to work through on some of these combinations, and you wouldn't. You would just do big red, the fundamental counting principle. So, seen down below is another example of cases, whereby it's going to be a lot easier to just use the fundamental counting principle, or a tree diagram, whichever. But some questions are going to be much more desirable to do cases. And we're going to do cases in this next example. Okay, more on to cases. How many 4-digit numbers can we make from the digits 0, 1, 2, 3 with no restrictions? So, how many 4-digit numbers? Blank times blank times blank times blank. 4-digit numbers. And the first digits, well, I can't choose 0. So I can only be 1, 2, or 3, and that's 3 examples. But now I can be 0 again. So I can be 0, 1, 2, or 3. That's 4 examples. And tick, tick, again 4, and tick, tick, again 4. And that is 192. 192 different numbers that we can make. So, same question. How many different 4-digit numbers can we make from the numbers 0, 1, 2, 3 without repeating the numbers? So the example above, we did repeats, no restrictions. Now we're not allowed to repeat. So, again, I'm going to list the numbers that we have to work with, and I'm going to set it up. So we have blank times blank times blank times blank, 4. And again, I can only be 1, 2, or 3 first, because I can't be 0, or else it wouldn't be a 4-digit number like we saw earlier, which is 3 examples. But then, let's say I used the 3. Well, now I have the 1 and the 2, but now I have the 0 back to choose from. So that's 0, 1, or 2. And that's 3 examples again. Interesting. Let's say I use the 1. Well, then I have the 0 and the 2 to use, which is 2 examples. Then let's say I use the 0, and then I have the 2 last for 1. And 3 times 3 is 9, times 2 is 18, times 1 is still 18. And, for example, we could have done that in a permutation. And you can see that in the examples, but I'm not going to go through all the different ways we can do each question. I just want you to know that there are many different ways to do each one. So now let's get more onto the point I mentioned about cases. We started talking about cases in the last example and how sometimes it's not useful to use cases, but lots of the times we have to. So again, a 4-digit even number this time. 4-digit even. Those important words I'm going to write down on the page. Even. From the same numbers. 0, 1, 2, 3. So again, blank times, blank, comma, or times blank times blank times blank. 4 digits. But we need to start thinking about this. What does this even mean? This big word staring us in the face, even. What does that mean? Well, last number of 0, 1, 2, 3 can be a 0, 0, comma, or a 2. So I can have a 0 or a 2 last. But if I use the 2 last, I still can't put the 0 first, which means that we're going to have cases. So, instead of 0, 2, 0 and another case with the 2 last. So in the first case, we put the 0 last. And in the second case, we put the 2 last. Because if I put the 0 last, I can put the 2 first. But if I put the opposite, if I put the 2 last, I can't put the 0 first. If I put the 0 first, I can put the 2 first. So, one more time. I'm going to look at the top example. This is confusing. I'm going to look at the top example. If I put the 0 last, I'm allowed to put the 2 first. So I'm going to put the 2 first. It can also be the 1 or the 3, which is 3 examples. Then let's say I use up one of those examples. Then I have a 2 or a 1, which is 2 examples. Then I'll use one up, and then I have 1 example, which is 1, and then I can only choose the 0 last, which is 1 example. Now, if I put the 2 last, I'm not allowed to put the 1 first. That's where we get this separate case. Case number 1 and case number 2. So if I put the 2 last, I can't put the 0 first, so I only have the options 1 or 3. 2 options. Then just 1, for example, but now I get the 0 back again, which is 2 options, and then let's say I have a 1 left, which is 1. Something above just happened. I'm just going to correct it really quickly. 3 times 2. And then again, 1 last, we're down back below again. A 2 last, 4, 2 times 2 times 1 equaling 4. The top one equaling 6. And we can add our cases together for a total of 10. So I mumbled on those words a little bit. I'm going to read right off the page. An even number must have a 0 or 2 last. If the 0 is last, we can use the 2 first. But if we use the 2 last, the 0 cannot come first. Therefore, 2 different cases. And we need to be able to recognize when we need to implement these different cases.